All right. So on to chapter 2. Uh, so in chapter 1, we talked about collecting data, just sort of briefly, gave some general guidelines there. When we have collected that data, so when that data is first obtained, they're called organizing raw data that we've collected into tables or graphs. And there are a whole bunch of different kinds of tables and graphs that we could talk about. We're just going to scratch the surface and talk about the most important ones, the ones that will come up over and over and over again. So in 2.1, we're going to talk about organizing qualitative data. And then in 2.2, we'll talk about organizing quantitative data. In both cases, whether the data is qualitative or quantitative, our first step into organizing data is to create what are called frequency distributions. So a frequency distribution lists each category of data and the number of occurrences for each category of data. Then you can also create a relative frequency distribution, which gives the proportion or the percentage of observations within a category. So to give you an example of that, here we have some raw data, right? In this example, it says a physical therapist wants to get a sense of the type of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. Construct a frequency and relative frequency distribution of the location of injury. And so here we just have the 30 observations, right? They haven't been organized at all into any kind of table or graph or anything like that. We just have a list of locations of injuries, right? So to construct a frequency distribution, we would start off by listing out all of the categories of information. In this case, we're talking about injury locations, right? So I'm going to say location, and then I'm going to say frequency. And then it asks for a frequency and a relative frequency distribution, so I'm also going to make a column for the relative frequency. Okay, so so let's fill in this chart now. So as far as locations are concerned, we had some back injuries, we had neck injuries, wrist, shoulder, elbow, back, we've already listed, knee, hip, hand, back, knee, back, shoulder, back, back, shoulder, knee, back, hand, knee, groin is a new one. And I think the rest of them we already have on the list. Okay, so those are all of the locations. Now we can go back through and count up how many times they happened. So back injuries, right? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 back injuries. Okay, I'll let you count up the rest. Okay, so I'll race you. Okay, so these are the frequencies I'm coming up with. Now, one way that you can check your work on this is when you add up all of these frequencies, you should get the total number of injuries. And in this case, we were told that she took a simple random sample of 30 of her patients. So we should get 30 when we add these up. And I think we do, right? 12, 13, 14, 15, 19, 20, 25, 30. Yep. So I think I got them all in there. So that would be a frequency distribution, right? Without the relative frequency column, that would be a frequency distribution right there. Now, relative frequency distribution is going to list the percentages now, right? So it's going to list off the percentage of times that each of these locations occurred. If we want the percentage of back injuries, we would say, well, 12 people had back injuries out of 30, right? So it was 12 out of 30 that had back injuries. So as a percentage, I'm just going to use my calculator. 12 out of 30 is equal to 0.4. Okay. And similarly for the rest of them, right? So we would do 1 out of 30 for this one. 1 out of 30 is about 0.033. I'll round these to 3 decimal places, right? 2 out of 30 and so forth. Right? So I'm not going to write out the fraction. I'm just going to say this is about 0.067 and so forth. One out of 30 we already did. 5 out of 30. 2 out of 30 we did. Okay. And so there's your relative frequency distribution. Now you can also check your work on this, because when you add up the percentages here, you should get 100%. And by the way, I'm calling these percentages, these are decimals. But one thing that you should get really good at is converting between decimals and percentages in your head. So I know that 0.4 corresponds to 40%. And I know that 0.033 corresponds to 3.3%. And 0.133 corresponds to 13.3%, and so forth. So when I add up these percentages, I should get 100% of the injuries, right? So if I add all this stuff up, I should get 1, or in other words, 100%, okay? And I think you probably do. Let's just check. 0.4 plus 0.033 plus 0.067 plus 0.133 plus 0.033, 0.033. Plus 0.167 plus 0.067 plus 0.067 plus 0.033 equals 1. Okay, so that works. It's possible when you're checking your work on these that you might get something a little different than 1. You might get like 0.999 or 1.00 here. So that's why. But you should get something 1 or really pretty close to it. Okay. So that's frequency and relative frequency distributions. Now, once we have frequency and relative frequency distributions, we can make frequency or relative frequency bar graphs or bar charts, or I don't know, whatever you want to call these things, but bar graph is what they're called in the textbook. But a bar graph is just a visual display of a frequency distribution. So, for example, this is all the this is the frequency distribution we just looked at on the previous page, but it's arranged into a bar chart, right? So there were 12 back injuries, right? 2 wrist injuries, 1 elbow injury, and so forth. Okay. This is a frequency distribution, or sorry, a frequency bar graph, because it's the frequency here on the y-axis. If you want to display the percentages on the y-axis, then you can do that, right? You can display the relative frequencies on the y-axis, and then this would be called a relative frequency bar graph. Now you'll notice that the shape is still the same though, okay? And then finally, if you want to arrange these bars so that they go from largest to smallest, then you can arrange them this way as well. And this thing is called a Pareto chart. Personally, I'm not going to like test you on what a Pareto chart is, but you might see it in the textbook, and so I just wanted to throw it out there, right? That's what a Pareto chart is. So let's practice making some bar charts. What I'm actually going to do, I think it's pretty straightforward, just making a single bar chart like this, right? But so what I want to do is practice making what's called a side-by-side bar graph. And we would make side-by-side bar graphs if we're trying to compare data from 2 or more groups. So here's an example of this. It says the 2000 census, which is way outdated. It's 2020. We've had 2 censuses since this, but anyway. But the 2000 census results include a summary of the racial composition of the population. The races reported by the populations of the United States and California are summarized below, right? So we have the US data here in this column, and then the California data here in this column. It says the data is given in millions. So when it says 174.6, it really means 174.6 million people, right? When it says 0.5, it really means 0.5 million people, or in other words, 500,000 people, right? Anyway, so that's how we would read this chart. You'll notice that this is not raw data, okay? The raw data would have consisted of a list of like, I mean, there are like 300 million people in the United States or something like that. So the raw data would have been a list of 300 million races, right? It would have been a list of 300 million individuals saying like white, black, Latin, black, Asian, white, you know? It would have been like a list of that stuff. Which would have been, we're really grateful that we don't have the raw data here. We have a summary, right? This is a summary. They've already given us a frequency distribution, right? So this is a frequency distribution that they're giving to us. And then part A says construct a relative frequency distribution for races in the US and California. So we already have a frequency distribution. Now we want to create a relative frequency distribution. So in order to do that, we're going to have to divide each of the frequencies in each of these categories by the total number of individuals in the categories, right? So, and in this case, that information wasn't given to us in the problem. Like they didn't say how many US residents and California residents there were. So we just have to figure that out ourselves by adding up, by totaling up the columns, right? So so I'm going to add these up. So for the US data, I would say 174.6. Let me put it this way: 174.6 plus 36.9 plus 34.7 plus 10.2 plus 2.9 plus 22.2. So that's 281.5. All right. So the total here is 281.5. So yeah, so almost 300 million, right, US residents. And then same thing for California. By the way, 3.8 should have been. Okay, so that's 34.4. By the way, you don't have to have a calculator for this class. You can just use an online calculator if you want, right? Just, you know, do a Google search for like calculator, and then a Google calculator will pop up. Actually, I'll show you. So I think I did this before I started. Yeah. So you could do all of your calculations here on the computer if you want. That's totally fine with me. Okay. Okay. So so now that we have those totals, we can construct our relative frequency distributions. So so I'm going to list off the races again. And then we're going to have the relative frequency. I'm just going to abbreviate So this is the relative frequency for the US, and then the relative frequency for California. Okay, and race. Okay, so we had white, Latinx, black. Oh, I should give myself more space. Anyway, Asian, American Indian / Pacific Islander, which is a strange category to me. Not because you're strange if you're in this category, but because, but it's strange because it seems like it's strange that they lump those two things together. Like American Indian, Pacific Islander, do they really have that much in common? I don't know. Anyway, other. Okay, and then relative frequencies. So what we're going to do to get the relative frequencies is we're going to divide each of these frequencies by their totals, their corresponding totals. So for the relative frequency of white people in the United States, we would say 174.6 divided by 281.5. Okay. For the relative frequency of Latinx people in the United States, we would say 36.9 divided by 281.5. Okay, but for the relative frequencies in California, we wouldn't divide by 281.5, we would divide by 34.4, right? So for the relative frequency of white people in California, we would say 13.1 divided by 34.4. And for Latinx people, we would say 13.3 divided by 34.4. Okay, and so forth. I'm not going to write out the rest of the fractions because it just it makes for a messy table. I'm just going to write down my answers, okay, from here on out. But I wrote these down so that when you look back at your notes, you understand where these numbers were coming from. Okay, but I'm just going to do the rest on my calculator now, and I will race you. See who finishes fastest. Should be a 281.5. I apologize. But anyway, this is about 13.1%. Oh, the rounding here is kind of interesting. 0.070, right? It's like, so you get this number, 0.0697, whatever. But the 69 has nowhere to go, right? The 9 has to go up to a 0, which means the 6 has to go up to a 7, right? So the 69 gets rounded up to a 70. Anyway, rounding is sometimes an issue for you guys. I've come to learn. You need to go back to 3rd grade and learn how to round, or whenever it is that you learn how to round. Okay, so that's what I'm coming up with. I'm not going to check my work on these, but you could, right? In the same way that we checked our work before. If you add all these up, you should get 1. If you add all of these up, you should get 1. Okay, there's our relative frequency distribution. We haven't made a bar chart yet, but I think that's probably part B. So part B is probably going to ask us to make a relative frequency bar graph or something like that. It says draw a side-by-side relative frequency bar graph comparing the racial composition of the US and California. Okay. So when you're making a bar graph, the first thing you need to kind of gauge is how to scale your axes. If we're making a relative frequency bar graph, what I would do is I would look for the largest relative frequency here. And I think the largest relative frequency is this one, the 62%. So that tells me that on my y-axis, I need to go up to at least 62%. So the way that I'm going to do that is I think I'll start at 0, and then I'll go up in increments of 5% until I get to 65%. And that way I've covered all of my bases, I guess. So I even have a little ruler here I'm going to use to make a straight line-ish. And I'll need a horizontal axis as well. Okay. Now here we go. So like I said, in increments of 5, maybe I should use pencil in case I make a mistake. I'm going to use a pencil in case I need to erase and start over. But I need to go to 65, so I'm going to do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Okay, well that's not terrible. I maybe didn't need to make my axis so long. That's okay. So, and then I'm not gonna label every one of these. I'm gonna label like every other one. Otherwise my picture gets too cluttered. And I should label the axis, right? So this is my relative frequency axis. And then down here I have, on my horizontal axis, that's where I'm going to put the races, right? So I'm going to put race down here. And what did we have? We had white, we had Latinx, we had black, we had Asian, we had American Indian, Pacific Islander, okay, and then we had other. So again, I guess I didn't need to make my axes quite so large. That's okay. I should also give my graph a title. So I'm going to call this thing racial composition. And I'm comparing the US data to the California data. So US versus California, something like that. Okay, now that I have all that groundwork laid, I can go back and start drawing my bars. So, for the white category, I need to draw bars at 62% and at 38.1%. So 62% and 38.1%. 62%. Well, this is 65 and this is 60. So 62 is somewhere in the middle. So it's maybe going to go up to here or something. I'm going to draw a bar. If I really wanted to be super neat, I could use my ruler, but I just don't care that much. There's my bar for white people in the United States. And then for California, it was a bar that went up to 38. So there's 35, there's 40, 38 is somewhere in the middle, somewhere right here. And I'm just going to go ahead and draw this bar right up next to the other one. And now to distinguish between which bar represents which group, you can shade in one of the bars. And if you have multiple groups that you're trying to compare, you could use like different colors or different kinds of cross hatching or something to distinguish between the groups. In my case, I'm going to color in the California bar so that I know the bar that's not colored in represents the US data, and the bar that is colored in represents the California data. And over here off to the side, I'll give the reader a little key so that they know if the box is not filled in, then that represents the US. If the box is filled in, then that represents California. Okay. And then I'll continue doing this with all the other groups. So 13.1 and 38.7. Twelve point 3 and 7. Three point 6 and 11. One and 1.5. So this is a tiny little group in both cases. And then 7.9 and 3.8. Okay, something like that. So you should get a picture that looks something along those lines. It's hard to be super precise about this when you're drawing it freehand. In 2.2, I'm going to show you how to do this using StatCrunch, and it'll do a much better job than we can do by hand. But that's the idea. I do want you to practice doing these things by hand, just because I think it forces you to really understand what the charts are saying and how to make the charts. You know, if you're sort of forced to do it by hand. But so yeah, so in this homework assignment, I'll have you do some of these by hand, but then in the future, we'll be making these charts using StatCrunch, okay? Anyway, let's see if we can answer some questions now. Part C says, what percentage of US residents is exclusively Black? So what percentage of US residents is exclusively Black? That would be 12.3%, right? Approximately 12.3%. And this is outdated information, right? So the percentages might be different now than they were in 2000. That's assuming that these percentages are even correct from the year 2000. They're probably not. Anyway, part D, what percentage of California residents is not exclusively Asian? So a couple ways that you could answer that question. One thing that you could do is you could say, well, 11% of California residents are exclusively Asian. So that means the other 89% of California residents are not exclusively Asian. So that's one way you could do it. You could say 100% minus 11% is 89%. The other way you could do it is you could say, well, if they're not exclusively Asian, so if they're not in this category, then they're in one of these other 5 categories. This one, this one, this one, this one, or this one. And so you could just add this plus this plus this plus this plus this, and that would also give you 89%. Okay. In either case, you would say, well, 100% minus 11%, right? So in either case, you would say 89% is your answer. Okay. So that's just kind of testing to see if you can read a bar chart, if you can read a frequency distribution, and so forth. Now, part E here asks a really good question, and it's been my experience that students actually struggle to answer this question, which is somewhat surprising because it seems really obvious to me, but but maybe it's just because I'm not asking the question very well. But the question is, why is it better to compare the relative frequencies of the US and California data than it is to compare their frequencies? So let's just remind ourselves, right? The frequencies are the counts, right? It's how many individuals there are in each category. The relative frequencies are the percentages. Or the proportion, right? So it's what proportion of individuals are in each category. And in this case, I'm claiming that it's better to compare the relative frequencies of the US and California than it is to compare their frequencies. And I'm asking you, why do you think that is? Why do you think that's a more why do you think that comparison illustrates more than comparing their frequencies? So give the video a pause and give that question some thought. Okay, now here's my answer to the question. The US and California do not have the same total number of people in them. The US has a lot more people in it than California does, right? So if you were to compare just the frequencies of people of each race in the US and California, then obviously the US is going to have a lot more people in each category than California does, right? So that really wouldn't teach you anything. It's like, well, that's obvious. I mean, California is part of the United States. So anybody who lives in California lives in the United States. And so obviously the United States is going to have more people in each category, right? It's just not going to give you any good information. But if you look at the relative frequencies of the US versus the relative frequencies in California, if you look at those percentages, right, then you get a much more clear idea about the racial composition of those two places, right? Like you can see looking at the bar chart that in the United States at large, there's a lot more white people than in any other category. But if you're living in California, then you see that, well, actually, right, like there are as many Latinx people as white people if you're talking about California. And of course, this depends on where you are in the United States. It depends on where you are in California. But as a general kind of rule of thumb, this is the case. So one thing that you might see by looking at the relative frequencies is that you can see pretty easily that California is a more diverse place than the US at large, right? We have a little bit less Black people in California than in the US at large, but we have more Asian people than in the US at large, right? And a lot more Latinx people than in the US at large. Or not more, but a greater percentage of our population is made up of these other categories than in the US. So anyway, so that's why it's better. If you wanted to write something down for part E, I'm not going to write something down. You can pause the video, you can rewind the video to figure out what to say there. But if you wanted something concise to write down, you could say something like, it's better to compare the relative frequencies so that it's more clear, so that the differences between the racial compositions in each of those places is more clear. So, or better yet, you could say something like this. You could say, we compare the frequencies rather than the frequencies so that the racial compositions are not affected by the total population size, right? Something along those lines. But anyway, that's that for 2.1.